In this video, I will be going over the rates of change in the natural and social sciences. For the example, I have that the height in meters of a projectile is shot vertically upward from a point 2 meters above ground level at an initial velocity of 24.5 meters per second is the height equals 2 plus 24.5 t minus 4.9 t squared after t seconds. So here, since it said that the initial velocity is 24.5, I know my v of 0 is going to be 24.5. And since it's shot from 2 meters above ground, I know that my initial height is going to be 2. And for the first question, it asks, what is the velocity after 2 seconds? So this question is asking, what is your v of 2? And our velocity here is going to be the derivative of our height function. So height prime of t equals v of t. And so our v of t equals, the 2 will cancel, and we'll get 24.5 minus 4.9 times 2t. Which will give us 24.5 minus 9.8t as our v of t. And since we want v of 2, at this point we will just plug in t equals 2. So we get 24.5 minus 9.8 times 2, and that gives us 4.9 meters per second. So our velocity at 2 seconds is 4.9 meters per second. Now for the second question, they ask, when does the projectile reach its max height? So for our maximum height, we're going to want our velocity to equal 0, or in other words, our h prime of t to equal 0. And the reason for this is that based on the graph, we start off at 0, 2, and it's an upside down parabola. So the highest point is going to be where it flattens out. And if this is our h of t curve, then where it flattens out is where h prime of t equals 0, or in other words, the maximum of the function. So here we know our h prime of t is 24.5 minus 9.8t. We're going to set that equal to 0. Then we get 24.5 equals 9.8t. And so our t equals 2.5 seconds. So after 2.5 seconds is when the projectile reaches its maximum height. And now for the next question, it asks, what is that actual maximum height? So since we know that it reached its maximum height at t equals 2.5, we want h of 2.5. So all we have to do here is plug in 2.5 to our h function. So we get 2 plus 24.5 times 2.5 minus 4.9 times 2.5 squared. That gives us 2 plus 61.25 minus 30.625. And then we are left with 32.625 meters as our maximum height. Now the next question asks, when does it hit the ground? Based on the previous graph, if the function looks like this, an upside down parabola, and we have our meters and our seconds, and this is our height curve, we want to find out what our time is when h is 0. So we're looking for this t value here. What does t equal when h is 0? So we're going to set h equal to 0. So we get 2 plus 24.5 t minus 4.9 t squared equals 0. And we're going to use the quadratic formula. So we get t equals negative 24.5 plus or minus 24.5 squared minus 4 times negative 4.9 times 2 divided by 2 times negative 4.9. That will give us negative 24.5 plus or minus 639.45 divided by negative 9.8. And we get t is approximately negative 0.08 and 5.08. So as we see, we can never have a negative time, so this will not be an answer. And we can also see on the graph that the only point that it hits h equals 0 is when t equals 5.08. So the projectile hits the ground when t is about 5.08. They want to know, what is the velocity when it hits the ground? So since we know that the time it hits the ground is approximately 5.8 seconds, we want the velocity when t equals 5.08. So plugging this in, we get 24.5 minus 9.8 times 5.08. And this is going to give us approximately negative 25.3 meters per second squared.